The summer of 2021 produced a lot of heavy, slow-moving downpours and caused quite a bit of flash flooding. Chard in Somerset in late June, Norwich and Peterborough in early July, and London actually was impacted on 2 separate days. One of them was on the 25th of July, and that's the focus for this particular video. We're going to be looking at an extreme rainfall event that affected this small village of Brettenham in mid-Suffolk. The amount of rain produced by this thunderstorm challenges some UK rainfall records, but it didn't make the headlines necessarily because it was happening over a fairly rural area. Had this moved over an urban area, then it could well have been much more noteworthy in terms of the amount of flooding that we've seen. Now, to look at things a little bit more detail, here's the Met Office analysis at lunchtime on that Sunday. We can see a fairly slack area of low pressure centred over northern France. We've got this decaying occlusion trapped over parts of East Anglia and the Midlands. It brought a little bit of drizzly rain in the morning, nothing more than that. Another small low that came out of Germany running northwards across the North Sea. So the axis between these two lows just to the east of the UK means we've got a gentle northeasterly breeze across East Anglia on this particular day, at least during the morning, before things start to change through the course of the day. Now, looking higher up in the atmosphere, this is at 500 millibars or hectopascals, so about 3.5 miles above the ground in the middle part of the troposphere. And we can see we've got this upper low centered over the eastern side of the English Channel. So whenever you see an upper low on the charts, you start thinking cold air higher up, and you can see the temperature at this level in the atmosphere, -16 at 3 or 3.5 miles above the ground. So with cold air higher up in the atmosphere, and it's the middle of summer, so you're going to be fairly warm much of the time at the surface, then you know it's probably quite unstable, probably some shower activity around, perhaps even a few thunderstorms as well, depending on the environment in one or two places. So we can look at that detail more using these tephigrams. This is for the middle of the afternoon now in South Suffolk, and the lower levels here have been modified for the conditions at RAF Wattisham at that time. And what we can see here then is a plot of temperature along the x-axis here, getting warmer to the right-hand side against height, and height here is measured as a function of pressure. The higher up in the atmosphere you go, the lower the pressure is. So what you would normally expect to see is the temperature gets colder the higher up you go, and the red line here is our temperature, and you can see it leans to the left, so it's getting colder, generally speaking, as you go up through the profile, until you get to the tropopause, which is the boundary for the stratosphere, and then it actually doesn't follow that pattern quite so much. Now, the dew point here, the green line, that's a measure of how much moisture there is in the air. So where the two are very far apart, such as up here, the air is very dry, but where the two are very close together, which for much of the profile they are, then the air is very moist, and that's obviously one of the key components for producing heavy rain from these thunderstorms. The teal color here, this curve, is our parcel. So to get a thunderstorm developing, you need to lift some parcel of air upwards to create that convective process. And as long as that parcel is warmer than the surrounding environment, it's still unstable, so the air continues to rise. So in this case, our air parcel is lifted from the ground and then rises until it passes to the left-hand side of our red line. And that's when things start to become more stable, and so the air stops rising and sort of gradually comes to a rest. But before you get there, you've got a big chunk of the atmosphere here that is unstable. And on this particular day, this profile gives us a CAPE value, so the amount of energy in the atmosphere of 1,100 joules per kilogram of CAPE. And that's fairly significant. It's quite a big amount of CAPE, I guess, for UK standards, but it is stretched over quite a long distance from the ground here. It's a very tall, sort of skinny CAPE in this particular profile. But the key things to note then, the relative humidity between the mid levels, the 500 millibar level, this line here, down to the ground, is 83%. So that's very moist. A lot of thunderstorms, the rain that comes out of them, some of that evaporates into the air around the storm before it even gets to the ground. But in cases like this, when the air is very moist, you get less of that evaporation going on, and so you get more heavier rain at the ground when the air is very moist, as we've seen in this case. And the cloud tops from these thunderstorms this particular day, they were measured as -52 by satellite data. So that suggests they got up to about 34,000 feet, which isn't too bad for UK standards. Obviously, in continental climates such as the US, these can get much, much higher than this. But for UK standards, not doing too badly at all. Now, on the right-hand side here, these are what the winds are doing through the depths of the profile here. They're pretty much easterly all the way up. There's a little bit of a southeasterly component near the ground, but fairly unidirectional, not massively strong either. So that suggests the storms would drift slowly to the west, but pretty slowly because there's not a great deal of flow going on higher up in that profile either. So it's an unstable profile. We know there could well be showers and thunderstorms. We know they'll be slow moving because of the light winds, and we know that there's going to be a lot of rain coming out of these as well. And that all means that there is that risk of flash flooding. So we know showers and storms could develop. The next question is, where are they going to develop? And this is just 4 examples of computer models that were run before the event. So this is the morning of Sunday, the 25th of July, 2021, and different computer models from different agencies here. This is the Met Office model, for example. This one is run by the Netherlands Met Service, and a couple of local WRF models being run here as well. Now, they all look slightly different, and that's because showers are near impossible to predict exactly where they're going to form and how they're going to behave. The first shower goes up, but then the outflow from that shower can influence quite significantly where the next showers form, and the models are never going to capture that brilliantly either. And so if you've got an app on your phone, chances are that app is using perhaps one of these models, but you might have more than one app, and they could even be using one of these other models. So that's why your apps can look different depending on which of these models, for example, that they're using. But either way, there is a good signal here for these big, heavy downpours to develop across inland parts of Suffolk in all of these models, some of them producing some very significant rain, over 100 millimetres of rain in these shaded areas here, and that one there is about 90 millimetres. So there is certainly that signal that there could well be a lot of rain from these slow-moving thunderstorms. One thing we could be confident about, actually, is that the coast would stay dry and clear on this particular day, as would the north of Norfolk and out across parts of North Cambridgeshire as well. So there's a good signal where these storms are going to develop and where they're not going to develop if you were trying to plan any activities on this particular day. So focus on the shape and the location of these heavy rain signatures in these models, because the next slide is going to show what the radar captured during that day. So this is actually what happened, not what was forecast to happen. And you can see it's very similar. The heavy downpours here across the western half of Suffolk into western Essex, the coast dry and clear for much of the day, and again North Norfolk across Cambridgeshire also dry for much of the day as well. So in a forecast sense, this was actually a pretty good forecast from those computer models about exactly where these thunderstorms would form. Exactly how much rain you get from them is hugely dependent on so many factors that are going to be very difficult to pinpoint in a site-specific detail. But what was interesting from this day, this was made at the end of the afternoon, using some of the unofficial weather stations in the region in people's back gardens. We could see that Brettenham in Suffolk had unofficially 161 millimetres of rain. So that automatically sets the alarm bells ringing that quite a significant event had happened here. Even in London, 120 millimetres of rain in northeast London, and there was a lot of flooding in this part of the capital as well. But even parts of Harlow, for example, 87 as well, and parts of Haverhill too, and even parts of the southeast saw rain totals up to 100 millimetres or more. So localised, slow-moving flash flooding events in quite a few places on this day. But clearly the bullseye here stands out in mid-Suffolk, and that's where the interest is for this particular talk. So to understand how things evolved through the day, as I say, the models are limited, so we want to know exactly how things formed from an observational perspective. So to do that, we created our own mesoanalysis using weather stations from across the region. Now, there are some of these Met Office stations, such as here at Weybourne in North Norfolk, but they're very sparse, and there's a lot of detail that you could get in between those weather stations that won't be picked up by them on their own. So what we've used is over 350 privately owned weather stations, such as this one here, which are in people's back gardens right across the region, and they upload their data freely to Weather Underground each minute of every day. And we've used that data to create this mesoanalysis. Now, we have removed any stations that have some dodgy wind data. So if the wind speed or direction looks a bit off, then they were removed from the analysis to try and avoid any sort of dodgy data getting into the analysis going forward. So this is what we're left with. This is a plot of temperature and wind flow, I guess, across the region. The shading here denoting how warm or cold the air temperature is. And you can see at 9 o'clock in the morning, this is centred over Suffolk, of course. We've got Norfolk up here and Essex down here. We've got this northeasterly wind across the whole region. It's pretty much uniform, because that's the synoptic background wind at this particular moment in time. Temperatures, first thing, 19 degrees in Ipswich, still 17 in West Norfolk. And the reason why it's cooler in West Norfolk is because we've got this area of low cloud, misty low cloud, and this did linger for a good chunk of the day, whereas we've got more breaks in the cloud, as you can see on this satellite picture from later in the morning, across South Norfolk into Suffolk and even parts of Essex saw some brightness as well. So there's that quite clear difference between where it was brighter and warmer and where it was rather grey and gloomy for much of the day. So by 10 o'clock, this is how things were looking. Again, still that northeasterly wind. Temperatures are warmed up to 20 degrees in Ipswich, but still, as I say, cooler to the northwest. And then we gradually see those temperatures rising further, 21 degrees, for example, by 11 o'clock. Now, that tephigram earlier suggested we needed temperatures of 22, 23 to set these showers and thunderstorms off. We start to get close to those values by midday, and we certainly get higher as we get to 1 o'clock in the afternoon. We start reaching 23 quite widely across East Norfolk, East Suffolk. But notice by this stage, the winds are not northeasterly everywhere. They still are in many places, but if you look closer to the coast here, they've turned more to the east or even the east-southeast across the Suffolk and Essex coast. And that says the temperatures inland warm, you start to get the winds flowing in from the sea as a sea breeze starts to develop. And the temperature difference between the land and the sea gets a little bit larger. So the winds shifting direction play a key role into how these thunderstorms formed on this particular day. And by 2 o'clock, 24 degrees quite widely across Suffolk now, and really that strong easterly wind, that easterly component coming in. And where that meets that northeasterly wind, you start to get a convergence line developing as those two wind directions meet. The air gets forced upwards, and that creates showers and thunderstorms, and is very much key for developing these sort of things on this type of day. So here's a radar loop. You can see it's pretty quiet at first, and then once we get through to about 1:30 onwards, once we reach that critical temperature, we start to see those showers and storms developing along these convergence lines during the afternoon, and you can see them popping off here pretty much where those models said they would during the early part of the afternoon. It's still pretty dry and quiet the further northwest you are. And just to show you what's going on from the water vapor satellite here, you can see the spin going on. This is our upper low sitting there over the eastern channel. You can see the showers and storms kicking off quite early actually across the southeast. And then as this drier air starts coming in across the North Sea and meets with that convergence line, notice the convection firing off across East Anglia as well. So all the pieces of the puzzle coming together at the right moment really to set off these showers and thunderstorms. So by 3 o'clock, quite a clear convergence line now developing through South Norfolk, North and West Suffolk into West Essex. Very warm and unstable to the east of this, with this onshore wind coming in from the southeast. Still a northeasterly wind to the north of our convergence line, and still relatively cool up here where we've got that cloud cover lingering. But notice even Cambridge is getting up to 23 with more brightness and sunshine coming through at this point. And then by 4 o'clock, we've still got that convergence line. Notice it's sort of wiggling around a little bit, so it changes position with each hour. And part of that is because of what the thunderstorms are doing. We've got those storms developing along this convergence line, and then the steering winds take them to the west. So they drift off to the west. They put out some cold air, some chilly outflow air, and that sort of distorts the shape and position of this convergence line. But it's still very much there and evident at 4 o'clock in the afternoon, 24 degrees in Ipswich, so it's still pretty warm. So this is how things evolve then. This is when things start to get a bit more interesting by the time we get through to about 3:30. So you can see where the showers and storms are at this moment in time. The first wave that's gone off on our convergence line, a few more down here. This red dot is Brettenham in mid-Suffolk. So this is the place that got flooded quite badly on this day. What we're watching for now is this shower that develops just to the southwest of Eye. It reaches its peak intensity about 4 o'clock in the afternoon. And as it dies and collapses, it sends out what looks like an outflow boundary, pushing southwards. And as that continues to push south, it really blows up into this fairly big thunderstorm across Brettenham. And it's here where we see that really intense downpours developing. But what's also interesting is actually these other showers here starting to brew behind it. And that also plays a part in what happened through the rest of the afternoon. So by 5 o'clock, our convergence line is still there. We can see it's still very warm and unstable with an onshore flow here as the winds are pretty much perpendicular to the coastline. Northeasterly winds this side of the convergence line, and still rain-cooled air here. So notice those temperatures are much lower here than they are further east in the sunshine across East Suffolk. Notice this little kink in the convergence line though. That's where things start to get quite interesting actually. And if we sort of zoom in a little bit more onto that, you can see here we are going to get easterly winds meeting a southeasterly and a southerly, all meeting in that one point. So arguably the convergence here is maximized, with very unstable air being feeding into this area and then being forced upwards in that convergence zone. And you can see on the radar what happens here. 5 o'clock in the afternoon. Brettenham's still very much in the epicenter of this thunderstorm here. This is where the storms are developing, and then they're sort of running west-southwestwards across Brettenham through the course of the afternoon. So some pretty intense downpours. And zooming into that, then you can see the shading here is our radar estimate of rainfall rate, really focusing on Brettenham here. And then here's our convergence line. Now, we can see these showers and storms developing here, and then the steering flow takes them west-southwestwards across Brettenham. But this portion seems to be fairly anchored for a couple of hours, and the convergence line here doesn't move too much. And equally, this bit down here doesn't move too much either. But what we find is this cold air, this blue shading here, is where the temperature has fallen greatest in the previous half an hour. And that is cold air, cold outflow coming out of this storm, buckling our convergence line. It's an outflow boundary, essentially, and pushing it down towards Ipswich. Notice it hasn't reached Ipswich at this point, but it's heading that way. So all that rain-cooled air pushing that out and sort of anchored still here. So maximum convergence creating these showers and storms. They drift southwestwards as they are maturing, reach their peak intensity over Brettenham, and then they weaken as they push off to the west-southwest. So by 6 o'clock, this is our convergence line. It's reached Ipswich. So that whole thing has pushed the convergence line down towards Ipswich. The white dashed line is where it was an hour before, and you can see how much it's moved in 1 hour. So all this rain-cooled air from the thunderstorms has pushed that convergence zone towards the coast. Still this onshore flow, and still warmer across Ipswich, for example, but also East Suffolk. But even here, temperatures are coming down from the earlier 24 values we saw. And as that temperature difference between the land and the sea reduces, that onshore wind will start to shift back round more to a northeasterly, back to what was the background wind direction. So the radar at 6 o'clock, still raining near Brettenham, but it's getting close to the end of the event at this stage. But notice these storms are well displaced now from the actual sort of forcing of this event, this convergence line. So they are going to be dying basically over the next couple of hours. And then by 7 o'clock, they're starting to weaken. There's a lot of light to moderate rain here, not a huge amount of new development going on. And you can see by 7 o'clock just how much cooler the temperatures are underneath all that rain-cooled air, and still fairly mild near the coast. But notice the winds are more easterly by this point, and then by the time we get to 8 o'clock in the evening, they've basically turned around to a northeasterly everywhere, which is where they were in the morning. So quite interesting to see the effects of the sea breeze, but also the effects of the thunderstorms pushing that convergence zone towards the coast before the whole thing sort of washes out as the sea breeze weakens during the latter part of the afternoon and into the evening. So this is a radar loop of essentially the whole event, and you can just see how each cell keeps firing in the same area just to the north of Stowmarket, and then they run down across Brettenham and reach their peak intensity, and then they weaken as they shear off to the west-southwest and eventually die away. So you can see Brettenham really happened to just be in the peak of the intensity of these thunderstorms, sort of the worst case, I guess, for getting all of that rain that particular afternoon. So what was interesting is actually the influence of the sea breeze, and I kind of threw this in as an afterthought, but it's basically looking here, the white arrow is sort of the average wind direction along this portion of the Suffolk coast, and you can see the sea temperature was about 18 degrees, so the winds northeasterly in the morning, and then as the inland temperatures start to rise, the wind starts swinging around more to the east, and then eventually round to the southeast by the afternoon. So you're reaching a maximum convergence, I guess, during the mid to late afternoon, and then as the temperatures inland start to drop away during the evening, those winds swing back round to the east and then eventually the northeast by the time we get through to the late evening. So very much highlighting the influence temperature between the land and sea affects the wind direction and the wind speed, actually, if you've got a sea breeze developing. So how much rain fell? Well, this map's using an estimate from radar, which has been adjusted for surface observations. So the red boxes here are our Met Office and Environment Agency rain gauges, so the official rain gauges, and they're dotted about, but they clearly missed the bullseye. So the highest, I think, was this one here with 87 from memory. But clearly the epicenter of this event was over the village of Brettenham, and quite a small area where the rain was really, really focused from this event. But luckily, many farmers got in touch with their rainfall readings, which are what these black triangles are, and really helped paint a clearer picture as to the sort of gradients of rainfall we've seen over the area. And we reckon it's probably over 180 millimeters of rain actually fell in the Brettenham area in probably just under 2 hours by the looks of the data. So this is just a sort of zoom in on the Brettenham area, the 161 that we had from that automatic weather station, and then a farmer just down the road 100 meters away recorded 181.3 for the day using this equipment, which used to be part of the Environment Agency network. It's no longer part of the network, but he still uses the same equipment. So it's pretty high spec sort of rainfall equipment here. You could take quite a lot of reliable readings from this. And then just down the road, another farmer got in touch and said they had roughly 200 millimeters of rain, give or take, because they actually had to empty the rain gauge twice because it kept overflowing during this thunderstorm. So there's clearly a fairly strong signature here for a lot of rain, and I think the 181 is probably fairly reliable based on the similar values nearby. But then just down the road, 43 millimeters just to the north of Hitcham, which is only 2.1 kilometers away, which would give you a rainfall gradient of 66 millimeters per kilometer. So you could be at one end of a village and you've got 66 millimeters of rain, yet the other end of the village you've bone dry. And that just really highlights how localized these downpours were. And there were residents in Stowmarket and other surrounding villages that were completely surprised by all the flooding that had happened in Brettenham because they had been dry all afternoon and they're only a short distance down the road. So it just really highlights how localized these big showers and storms, especially when they're slow moving, can be in the summer season. So we tried to verify how long that thunderstorm lasted for if we're going to consider it for any sort of record as well. So what we found is there was an earlier shower in the afternoon. Now this wasn't mentioned by the farmer that had that Snowdon rain gauge, so I haven't put it in here. But it was picked up by radar estimates. So on here we're using the highest radar grid cell, which is just north of Brettenham actually, and the nearest grid cell on the radar to where the Snowdon rain gauge was. And you can see that plus the automatic weather station here picking up that shower earlier on in the afternoon, but actually the tipping bucket rain gauge here only got 0.8 millimeters, so it wasn't very much rain at all, but something to take off the event total, I guess. And you can see later on in the afternoon just when that thunderstorm started. So it's about 4:30 local time, because these are in UTC, and it ran through to roughly 6:30, give or take 5 minutes or so. The purple here is obviously when the farmer with the rain gauge suggested the start and end times were. And we've used these two radar bars here to try and estimate exactly how quickly we got to certain accumulations. So what's interesting is actually in the first shower, the automatic weather station recorded less rainfall than the radar estimates. But in this second batch with the thunderstorms, the automatic weather station tipping bucket recorded higher totals earlier than the radar, so implying that actually the radar was underestimating the intensity of the rain coming out of these storms. And so that gives us more confidence that actually these large numbers were probably fairly reliable compared to these lower numbers being reported by the radar estimates. But whenever the rain started and stopped, it was a maximum of 2 hours long, so quite likely less than 2 hours. And so we know that 180 odd millimeters, if you take 181.3 and remove the 0.8 from the earlier shower, we're talking about 180.5 millimeters essentially in 2 hours or less. So that's an awful lot of rain to fall in a very short space of time. Now this table here is some of the records in the UK for 1 and 2 hour rainfall duration. So we'll start with the 2 hour one first, that's the easy bit. 180.5 for this event ish estimated. You can see how that fits in with some of the other historical events in the UK, and really there's only one event, the Walshaw Dean Lodge event here, where they had higher 193 millimeters, but this is disputed. There's much more information in these papers. I won't go into that in this talk, but the next highest 155 millimeters, so we're far beating that for the amount of rain to fall in 2 hours. So it sits up there as one of the most intense 2 hour rainfall events to be recorded in the UK. But of course this is all estimated. It's not from an official gauge, so this wouldn't be considered as a record, but it would fit in the table just for interest purposes, if nothing else. And then for the 1 hour event, the highest 1 hour accumulation from the radar was between 1545 and 1645 UTC, and that was 108.8 millimeters. But we know the radar underestimated compared with what actually happened. So if we scale the radar up, so we scale that value up using the same scaling factor we've used for the event total, then we get 134 millimeters, and that is way higher than anything else that's been reported in 1 hour from these events in the UK. So a very significant event for the sheer amount of rain to fall in such a short space of time. Never seen before, at least during reliable records in Brettenham for the last 60 odd years or so, and probably before that as well. So in terms of the impacts, well, we know there was significant flooding. At least 29 properties were flooded, mostly due to runoff from the fields and the roads. So roads looking like this during that afternoon. The intensity of the rain and the small hail actually flattened a lot of crops, and this is happening right at the peak harvest season, so not good for farmers in the area. Suffolk Fire and Rescue Service say they had 37 calls from the area, but most of them were actually from Haverhill, not from this area, from a separate storm to the west. And there were 83 lightning strikes, but no reports of lightning impacts at all in the area as well. These are cloud-to-ground lightning strikes. There were way more lightning strikes that were intra-cloud. But yeah, a very active afternoon, an awful lot of rain and quite a bit of flooding, but it could have been a lot worse had this happened over an urban area, that's for sure. So thank you for listening. There's plenty more on this particular topic in a paper that's been published online, and hopefully it will be published in print later in 2022. It's in the journal Weather, so you can go onto that link there and read up more information. Hopefully you found this interesting, and thank you very much for listening.